The basics of functional dependencies. Basics of functional dependencies. Functional dependencies. Okay. See, what is a functional dependency? How can you define a functional dependency? You can say functional dependency is a constraint between two sets of attribute in relation from a database. You can define the functional dependency as functional dependency is a constraint between two sets of attributes in a relation from a database. Okay, from a database. And in second way, you can also say the functional dependencies as functional dependency is the generalization of the concept of keys. Okay, and we generally represent a functional dependencies like this: x determines y. Says that if two tuples agree on the value of attribute x, then they must also agree on the attribute y. Okay, so we read this one as x determines y, or you can say with the help of a unique value of x, you can determine every unique value of y. For example, let us suppose if there is a class. In a class we have students, and for those students we have roll number and their name. If I give you a roll number, uniquely you can tell what is the name of the student. That means with the help of one roll number you can uniquely determine the name of the student. But if I give you a name, for example the name is Himanshu, and that class may be having 2 or 3 students who are having the same name, then with the help of name you cannot uniquely determine the roll number of that particular student, right? It can happen. So when I am saying x determines y, that means with the help of x, if I give you one record of x, you can uniquely tell what is the value of y. Okay, so when I'm saying x determines y, it says that if two tuples agree on the value of attribute x, then they must also agree on the value in the attribute y. Okay, so for example, let us take a very simple example of a small relation. Assuming that we are having 4 attributes like a, b, c and d, and assuming that we are having some values of a, b, c and d. The values are as follows. It is a1, b1, c1, d1, a1, b2, c2, d1, a2, b2, c1, d2, a3, b3, c2, d2, and let us take 2 more values here. So they are a4, b4, c4, d4, a5, b3, c3, d3. Assume we are having these values. Okay, this is a relation. This is representing a relation. Now when I'm saying a determines b, when I say a determines b, that means if I give you a unique value of a, you will be uniquely able to determine every tuple of b. Right? For example, again, if I give you a roll number of a student, then you can uniquely tell what is the name of the student. Therefore you can say roll number can determine name, but if I give you a name of a student, then you cannot uniquely tell what is the roll number of the student, because there may be multiple students who are having the same name. Now you can see when I'm saying A determines B, in this particular case A determines B, if I give you a value of A, right? For example, if I'm giving you the value of A is A1, now can you tell what is the unique value of B? For value of A, if the A is repeated 2 times, there are 2 different values of B, like that is B1 and B2, and there's a confusion between them. That means if I say that the value of A is A1, so you can say, sir, for value of B can be B1 or B2, I'm not sure. B1 or B2, I'm not sure. Therefore, A cannot uniquely determine B. A cannot uniquely determine B. Okay. Now if I say I have like A determines C. Can A determine C? Can A uniquely determine C? Let us see. If I give you a unique value of A, can you uniquely determine the value of C? See, A is repeating 2 times here. In both the cases, the value of C is different. Therefore, A cannot determine C. A cannot determine C. Now, can I say that A determines D? Can I say A determines D? Now, here, these are the 2 cases when the value of A is repeated. In both the cases, the value of D is D1. So, it is a unique value. It is a unique value because if I give a value of A, for example, if I say the value of A is A1, value of attribute A is A1, so you can uniquely say the related value of D is D1. You will not be confused. In the same way, if I say what the value of A is A3, then you uniquely say the value of D is D3. Okay, D2, that is D2. Okay, so that is why you can uniquely determine every value of D with the help of A. Therefore, A determines D. This functional dependency does hold. This functional dependency does exist. Okay. In the same way, can I say B determines A? Obviously, I cannot say. Why? Because if there are 2 different values of B, but these 2 different values are associated, 2 same values of B are associated with 2 different values of A. Therefore, I can say B cannot determine A. Okay, so this does not hold. Can I say that B determines C? So here there are 2 different values of B. For these values, C is acquiring 2 same values of B. For these values, C is acquiring different values. Therefore, B cannot determine C. Right? Can I say B determines D? B determines D. So for these 2 values, obviously D is containing different values. Therefore, B cannot determine D. Okay. Can I say C determines A? With the help of C, can you uniquely determine every value of A? But you cannot do that. Obviously, why? Because for C1 and C1, we have 2 different values of A. In the same way, for C2 and C2, we are having 2 different values of A. Therefore, you cannot uniquely determine A. So C cannot determine A. Right? Can I say C determines B? C determines B. Does this functional dependency hold? So if C is repeating, again there are 2 different values of D, therefore C cannot determine B. Can I say C determines D? So if you check D, here for 2 different values of C, D is containing 2 same values of C, D is containing 2 different values, therefore C cannot determine D. Again, you can make different functional dependencies, like can I say D determines A? Can I say D determines B? Can I say D determines C? Can I say D determines D itself? That is trivial, that I'll tell you why it is always possible. But here again, can I say D determines A? See here, these are the 2 values of D which are repeating, and for this the value of A is not unique. Therefore D cannot determine A. Can I say D determines B? You can see here in the same way, here the value of B is not unique. Therefore D cannot determine B. Can I say D determines C? Obviously D does not determine C. So these are the functional dependencies which does hold. These functional dependencies hold. Only one functional dependency hold here, that is A determines D. Now I can also take the combination of some attributes. It is not the case that you have to take a single attribute every time. You can take a combination of attributes. Like, can I say AB determines C? That means if I combine both A and B, then does they determine C uniquely? See, what are the combinations which are possible if you do AB? For AB, the combinations which are possible, they are A1B1, A1B2, A2B2, A3B3, A4B4, and A5B3. So you can see all these combinations are unique in themselves, they are not repeating. So if they are unique in themselves, they can obviously determine C, because when they are repeating themselves, then we have to check whether it is containing the same value in C or not. But if they are not repeating themselves, then obviously there is no problem, right? So AB can determine C. This functional dependency does hold. In the same way, can I say AB determines D? Yes, it does hold, because every value of A is unique. Okay. In the same way, can I say BC determines A? BC determines A. That means you take a combination of B and C. Does it determine A? You can see for all these combinations of B and C, all these combinations are unique. There is no combination which is repeating itself. Therefore, BC can determine A. Can I say BC determines D? Obviously, BC determines D does happen, because they can uniquely determine every value of D, because all these combinations are unique. In the same way, I can take any combination of these attributes. Maybe I can take AD, maybe I can take CD, maybe I can take BD, maybe I can take ABC. I can take any combination of these, and I can see, does this combination determine any other attribute. Okay, so this is the functional dependencies. That means when I'm saying there is a functional dependency, it means with the help of this functional dependency, can you determine every value of the other attribute uniquely? Can you determine every value uniquely? Okay, so right, so if I say how to determine functional dependency, we can say given relation R, right? So when I say given a relation R, given a relation R, a set of attributes X in R is said to functionally determine another set of attributes Y also, which are also in R, which is generally written as X determines Y. So if and only if each X value is associated with precisely one unique value of Y, one value of Y, then R is said to satisfy the functional dependency X determines Y. Okay, so in this complete definition, one thing that is very important is that set of attributes. We can have a set of attributes. Again, here I have written a set of attributes, right? For example, I can say that X is having a set of attributes A, B from this table, and Y is representing a set of attributes C, D. I can say X determines Y. That means I can say AB together can determine CD uniquely, right? So that is, this kind of functional dependency does hold, right? So if maybe a single element is also creating a set, and we can have more than one elements in this set. Okay, and with the help of these functional dependency, if you can find out some basic functional dependencies from any given relation, then there are a lot of applications of those functional dependencies. Like we can find additional functional dependencies. That means what are the different other new functional dependencies which does hold on this given relation. Second, we can identify the keys in the relation. Keys can be candidate key, primary key, or super key. Third, we can identify the equivalence in function dependency. That means if I give you some function dependencies, can you say these two set of functional dependencies are equivalent or not? And number 4, we can find the minimal functional dependencies on minimal functional dependencies set. That means if I give you a big set of functional dependencies, can you minimize this set so that you will be representing the same information but with less number of functional dependencies. Okay, and with the help of these functional dependencies, we'll try to find what are the candidate key, what are the super key, and what are the primary key. We are going to see this topic, how can we find candidate key, super key and primary key from some given set of functional dependencies. Okay, now consider this example. This is a previous year question which is asked in the examination. They are saying consider relation R. Consider a relation R which is A, B, C, having the tuples given below, having the tuples like this which is given below. R, A, B, C has 1, 2, 3, 4, 2, 3, 5, 3, 3, 5, 3, 3. Okay, now they are asking, then which of the following functional dependencies can you infer does not hold over R? That means which of the following functional dependencies does not hold over R? Option A determines B. Option B, BC determines A. Option C, B determines C. And option D, AC determines B. Which of the following functional dependencies does not hold? Okay, now you can see the first functional dependency is A determines B. That means with the help of a unique value of A, can you determine B? Yes, you can do it. Why? Because all these values are unique. There is no value which is repeating itself. Okay, therefore you can do it. Second is BC determines A. So first of all, check with B and C, is every value unique? No, it is not unique because 2, 3 is repeating two times. If 2, 3 is repeating 2 times, then check whether A is having a unique value in both the cases. But here you can clearly see A is not having a unique value. A is having value 1 and 4 which are not unique. Therefore, given BC, you cannot uniquely tell what is the value of A. Therefore, this does not hold. Option number C, B determines C. Can you say B determines C? Yes, I can say that. Why? Because if the values of B are repeating, in both the cases C is containing a unique value, that is 3. So this does hold. Third is AC determines B. Yes, AC does determines B because all these combinations are unique. 1, 3, 4, 3 and 5, 3. All these combinations are unique. Therefore, this does hold. So the functional dependency which is represented by the option number B, that does not hold. Okay, now let us consider the next question. So in this question they are saying consider the following relation instance where we have the attributes x, y and z. It is having the values 1, 4, 3, 1, 5, 3, 4, 6, 3 and 3, 2, 2. Now they are asking which of the following functional dependencies are satisfied by the above instance. That means what are the functional dependencies which are satisfied here? The first one is xy determines z, comma z determines y. Second one, or option number B, you can say option number B is saying xz determines x and y determines z. Option number C is xy determines z and z determines x. Option number D is xz determines y and y determines z. We have to tell which of the following function dependencies does not hold. So let us take the first case when xy determines z. So let us see if you take every value of every combination of xy, or are all these combinations unique? Yes, all the combinations are unique. That is why xy determines z. Can I say z determines y? I cannot say. Why? Because z is repeating 3 times. These values are repeating 3 times and they are associated with different values of y. Therefore, z cannot determine y. Okay. Next is xz determines x. Xz determines x. You can see if you take all these combination of x and z, then is there any combination which is repeating itself? Yes, there is one combination, that is 1, 3 is here as well as 1, 3 is here. That means if you take a combination of x and z, there are 2 combinations which are repeating itself, but it is determining x itself, right? So because for this combination x is containing a unique value. By the way, this kind of functional dependency is also called as trivial functional dependencies. Trivial functional dependencies is if we have some x determines y, where x and y both are set of functional dependencies and y is a subset of x, then you can say this is a trivial functional dependency. That I'll cover in later videos. Just giving you a hint, if we have a, b, c determines a, b, you can see this part is a subset of this part. So this kind of functional dependency is trivial and it always does hold. So this one is also true. Can I say y determines z? Yes, I can say y determines z because y is containing all the unique values. There is no value in y which is repeating itself. Okay, So option number B is correct. If I say the option number C, xy determines z, can I say xy determines z is true? Yes, it is true, because that is creating a unique combination. Can I say z determines x? No. Why? Because 3 is containing a value of 1, as well as 3 is containing value of 4, so it is not valid. In the last one, the xz determines y. If I take xz determines y, it does not hold. Why? Because xz is having 1,3 and 1,3. For this combination, y is having 2 different values, therefore this does not hold. So you can see only the option number B hold, other options are wrong, because there's at least one value, at least one function dependencies which are given in those options which does not hold. Okay, so in case of functional dependencies, there are some axioms which hold, like they are also called as Armstrong's axioms. Let us look at those axioms. Axioms are these are kind of inference rules, or you can say set of formulas.